Thank you, Daniel, to be there. So, Daniel Berio is a software developer, artist, and designer from Florence, Italy. He is a lecturer at computing department in Goldsmiths University of London. Artistically, Daniel comes from a graffiti writing background, and he explores the same aesthetic in algorithmically generated forms. And now I give the floor to the Dr. Daniel Berio.
Hello, can you see my screen?
No.
Okay, so we need to find a way because I think I'm sharing. That's what Zoom says, but maybe I have to change. Oh, yeah. Cool. Okay, hi everybody. I wish I was there. And okay, so Simone already, thanks for the introduction. And so I'm working at Goldsmiths, and I'm going to talk mostly about graffiti art. You all know it. The conference is also revolving around it. And I also come, as Simon said, I come from a graffiti writing background. I did it for many years. I still do it once in a while. But one thing, because I've been working a lot with coding, one curiosity that came to my mind is how can I replicate certain aesthetics that I have in graffiti art that I do like instinctively, and how can I replicate those with rules, with code, right? So in time, also in my artistic practice, I ended up looking for merging those two aesthetics together. And I came up with this concept that I call graffitization, which is essentially like trying to transfer the style that is characteristic of graffiti art, and especially maybe my personal style, to computational generated forms, right? And computers have this power, right? Any type of data in, you can transform it and stylize it. So the idea is how can I have this aesthetic in what I'm generating? And another thing that I'm keen, right? Graffiti is made on surfaces, is made in the real world. And one thing I was always interested in is how can I bring it back to the real world, right? And computers also allow you this because you can connect a computer to a machine. And so I've been experimenting a lot with different types of drawing machines. And that goes from plotters, things that draw in 2D with a pen, to robotics. So working with articulated robot arms, which are a bit more complex to control. So in this presentation, I will kind of like go through the process I've been following, and I will show some examples of how I've been bringing things back to the real world, right? And so this has been like a journey, right? So I initially was like experimenting with code, and eventually like I had the opportunity to do a PhD about this. So I really was diving into the like more technical side of things for a few years. And so part of what I'm going to present will be also kind of technical, but I will keep it easygoing. So let's start with graffiti. The basis of graffiti art is tags. And to some people, those look like messy scribbles. To graffiti artists, there is a very specific aesthetics. For instance, I consider those a lot of very good tags. And it's interesting that actually there is some very characteristic styles. Those are examples of early tags in Paris, and they have this very characteristic rounded style, which I find very beautiful. And again, some people think it's vandalism. I like the aesthetic, and I've always been fascinated by it. And how do you achieve this aesthetic? Basically, tags are a form of urban calligraphy, and they're based on strokes, right? So strokes, you can think about it also in the typographical sense. I put my hands forward that I'm not a type designer, so I might say some things that don't make sense to a typographer. But stroke also in the sense, I'm a big fan of Gerrit Norzi. I don't know how to pronounce his name, but he wrote this nice book called The Stroke. But so in general, the idea is that you make a movement and you leave a trace, and the movement, the way in which you make this movement, determines the style of the tag. And this is related also to normal calligraphy, but in graffiti art, you do it on walls and on surfaces. So how do you get this aesthetic? Being a graffiti artist myself, I'm not a great tagger, but I've done a lot of tags. And how do you learn to do it is by repetition and by practice, right? So you learn those movements so well that eventually they become instinctive. You stop thinking about them. And with practice and practice and practice, eventually you get this aesthetic where your pen flows, where you don't hesitate. And when you look at the tag, actually, you are seeing the trace of this movement, but the way in which we judge them naturally as graffiti artists or also calligraphers, I guess, is the quality of the movement. And I used to do more design. I do less now, but I always found it frustrating. Being a graffiti artist, people will be like, hey, can you make this like poster with a tag or something? And then, take it to like Illustrator. And you're trying to generate something that you would generate by hand with Bezier curves, right? So I was always frustrated by this process. And I found it kind of difficult to work with. Another approach that you could be using when you're generating a tag with a computer, right, when you're trying to design it, is using some capture device, right? So you can make a nicer movement. But then what if I want to change something, right? You end up with what you can call a soup of Bezier curves, a lot of small segments, and you cannot make modifications. So when I was doing my PhD, I was kind of focused on, part of the focus was initially on tags and how can I reproduce those tags and create tools that help doing so. 1 minute. Checking if everything is okay. Yeah. So going on. So I started looking into, I got into, let's say, a rabbit hole of looking into literature of scientists that were looking at movement, at handwriting, at motor control, especially a field known as graphonomics. It's less well known. It's a field where people have been studying handwriting for many years. And you can find some very consistent underlying principles when you study human movement, right? So you can see that when you move from one point to another, you do like a line like this, you get, and that's not only with hands. If you look at the speed of the point, you get this bell-shaped like speed profile, right? So you have like, you kind of accelerate and you slow down. And the same is actually, it's interesting. Also, if you move with your feet and you move with your elbow, you will have the same characteristic kind of bump, right? And you can think of more complex movements as a combination of those straight movements. So instinctively, let's say that I'm doing this S-like shape, right? I will start pointing from P0 to P1, right? And while I'm still moving in this direction, I will start moving in this other direction. And that's how you can create a curve, by essentially overlapping in time those kind of straight movements. And another characteristic thing that has become useful in what I was doing is that essentially when you have a sharper turn, you slow down. So curvature and speed are inversely proportional. So those are just kind of principles that you can use when you're trying to generate those curves. And the idea, if you go back here, you see you have kind of a structure, right? You have like a very simple polygon, and which you would call a control polygon when you're working also with Bezier curves. And you can think about that as a structure, as like a plan for your movement. And different stylistic variations can be seen as variation of this movement that follow this structure. So the idea was to explore this to create stylizations. And so one thing that I found, right, I was thinking about my own movement. I was like, I think I kind of accelerate like with this bump, like profile. And I found work by a professor in Canada, which was studying this in the context of handwriting. He developed this computational model called the sigma log normal model. The name is scary, but it's actually quite simple. And it implements exactly what I just said, right? So you have you can think about, a corner, you make two straight movements and you kind of almost stop. But if you kind of overlap those movements, you see those two bumps get close together, you get those curves. And you can actually take those things, sum that together in time, create curves, and you create an interface. You can create an interface out of it that is an alternative to Bezier curves, let's say, right? And allows you to create a movement, a curve, but at the same time describe a movement that is similar to what a human would do. So essentially, this is an example of how you can take those principles, put them together, and create an interface that is simpler to use for this task, right, of generating something handwriting-like than Bezier curves. And again, one out of this, you are able to create an animation of the movement, which is somehow kind of realistic. And another thing that you can take advantage of here, because you have this kind of variation in speed, technically you call it kinematics, that is somehow realistic. So you have a slowdown at the beginning, and when you're faster, moving in straight lines, you're moving faster, right? So you can use that, for instance, to create brush effects that would not be possible otherwise. So for instance, here you can take a very simple concept, right? So if you move faster, you leave less ink, or if you slow down, you leave drips. So that allows you to create kind of simulations of brushes that take this movement into account. So this is kind of technical work that ended up being quite technical, but the idea was to create technical elements that I can then use to create visuals. Another thing that is nice about movement, right? So you can kind of have this simulation of a movement that creates a tag. And then by varying those movement parameters, you can generate variations. And those variations would be difficult to achieve if you were to use, for instance, a captured movement. So here I'm just essentially varying those overlaps between those straight movement speeds. But now what I showed you here, right, those are like manually, I have an interface, I did define those parameters. So one question that was coming more and more is like, how do I automatically choose those parameters? And this connects to what you guys were talking about before, right? So one way to do this is to take them from data, right? And where can I get a lot of tag data? And there is this amazing database that's been collected over the years. I can never pronounce the name of the website. It has too many zeros. But the idea is that Evan Roth and others created this, what is called the graffiti markup language, which is essentially an XML file containing movement data. And they collected lots and lots of tags. So what I tried to do is take those movements that are samples similar to what Felix was showing, right? Like taking with some capturing device, samples of a movement at a certain sampling frequency. And the idea was, how can I recover those movement, like those essential like straight line segments and how they overlap from this data. So we managed to do that. And once you have that, you can, for instance, start doing things that would not be possible to do with the original data. So for instance, here you have a reconstruction of a tag taken from this database, and then variations of tags from this database made by changing those movement parameters. And another thing we did is, the idea is like thinking about these movement parameters as style. And so the idea is like, how, if you take this, like, this kind of polygonal representation of the movement as the structure of a tag or of a letter, and the movement parameters as a style, the question is, how can I give you a new structure? So for instance, here, this is an example from the graffiti database, right? So how can I take a new structure of a tag or shape, and how can I apply this kind of style through movement parameters to that? And that can be done through machine learning. So the idea is that we learn this mapping from examples, right, from the structure to the movement parameters, and apply it to a new structure. And that allows you to create a stylization of the structure that kind of looks like a tag with somehow, maybe we could say, some stylistic variation that is similar to the input. And here are other examples of this, right? So on the left, here is the structure plus the tag. reconstructed with a certain movement, and this is the same structure repeated 3 times with different stylizations which are based on the movements from the examples, right? And all those examples come from this graffiti database. So again, like a recurring question, how can we generate those movement parameters automatically? Because in the example before, I was having an interface and doing it manually. So I went back to the literature of motor control. And another quite intuitive concept is that our movements, when we were like doing tags and stuff, tend to be smooth, right? And you can describe this smoothness as some form of optimality, right? So we try to minimize, we're trying to be optimal in terms of some cost or performance criterion. And one way to describe this cost, this thing that you want to minimize, is using what is known as minimum square derivative, which intuitively means minimizing the change in acceleration. So let's say acceleration is change in speed, and change in acceleration is known as jerk. And then you can minimize the change in jerk, which is known as snap, and minimize the change in snap, which is known as crackle, right? So you're changing those kind of like high change rates of the movement, and you get very smooth trajectories. And another principle known as the minimal intervention principle says that essentially intuitively, right, like if you want to be very precise, let's say you want to make a corner, you're going to slow down, right? You have to slow down to create the corner. If you're free to vary a lot, right? So if you have the freedom to vary a lot around a certain area, you can make a smooth curve and move very fast. So intuitively, lower precision with higher variability means a reduced effort and thus a smoother trajectory. So you can implement this in code explicitly, essentially. And those ellipses that you see here define how the movement is allowed to vary, right, in a certain area. And you can think of it as before, right? You have this kind of control polygon made of, in this case, 4 points. And here I'm saying, okay, here the movement can vary in this area that is not circular, right? It's kind of an area that is elliptical. And here it needs to be a bit more precise. And then, as you see here, you have more variation and the curve is smoother. Here, it decided to go not so smooth, but it would be allowed to vary based on the whole optimization of the trajectory, right? And again, you can create an interface for this where you define the curve not with handles, which you typically use with Bezier curves, but you use variability, right? So you define those areas that define how the trajectory varies. And you can generate kind of like more directional effects by defining ellipses. And those ellipses define a direction in which the movement tends to go. And I found that this allowed me to generate quite easily effects that I kind of see in tags. Again, not very scientific. On one side, scientific because there is a lot of math involved, but the other side, not very scientific because I'm using my personal taste as a graffiti artist to decide what to do here. And another nice property of this is that you're essentially defining like what you can call a distribution of movements. And then you can sample the variations based on how you define them initially in the interface. So you see here, I have a higher variation and a higher variability of the trajectory, right? And again, question, how can I do it automatically? Because here you saw that in this other slide, right? I was like manually defining the variability. Another trick that comes in handy is that you can define a similar orientation on all the variabilities on those ellipses, essentially, of the trajectory. And then by varying those together, you get a form of coordination in the movement. And interestingly, in all this research that has been done, mostly in the 80s in the Netherlands, they found that if you have to describe the way in which we handwrite, our hand, the way in which it's built, creates a coordinate system that is not orthogonal, so it doesn't have 90 degrees, right? It's oblique. And indeed, if you do this variation where you create circles become ellipses, you're actually describing this kind of coordinate system. So it's kind of interesting to find that varying those variabilities in ways that are non-orthogonal generates patterns that kind of look a bit like tags. So this ended up being something that I use a lot in my more artistic work. Here is another more technical example, a structure we saw before, and here we're generating with an interface a lot of variations of the tag. Again, because you're generating a movement that is kind of realistic, you can have brush effects that take speed into account, which is very basic. It's not really like that when you draw, but it works. And here is an example. Again, this ties back to the presentation earlier, which was very nice and gave me ideas. But here is how can you generate something that a bit looks like handwriting automatically. And what I did here is quite simple. The idea is you take some random points, more or less on a circle, and then you connect them with the longest distance path that can cover them, right? So you try to create strokes that connect those points with what would be known in kind of computer science as the traveling salesman problem. So where you're trying to minimize the length of the path, here you're trying to maximize it, and you get those patterns. And again, because the system generates movements that are kind of similar to what a human would do, you get these animations that are somehow a bit natural looking. And again, materializing, this is a very messy plotter that I built. Again, thinking about graffiti also in the physical way. So as a graffiti artist, I like drips. So I built this plotter that creates drips. It's very messy. You got very dirty when you use it. And I've been trying more and more to work with robotics. Here's an example of using the same technique. This is a lab in Germany, in Constance University, where they have this big industrial robot repurposed for painting. And again, because the system I just showed you allows to work essentially with any dimensions, I'm working mostly in 2D, but you can kind of optimize also the pressure of the brush. And here it's this applied not to letter likes, because what I showed you so far wasn't really letters, but applied, for instance, to create stylized portraits. And yeah, that's it. And this is another project I did with an artist based in Germany, Liat Greiver, and another artist based in Germany, Nora Al-Badri. And here the idea was to kind of try to capture the aesthetic of Kufic calligraphy from Islamic art. And essentially, again, here you see those structures. Those are generated computationally based on a paper, nice paper that I think Iraqi or Iranian architects wrote. And essentially, you can generate the curves, like a calligraphic-like aesthetic to it by using this system. Again, we have a robot. This is another robot they have in Germany, and it's drawing those texts on a scrolling piece of paper. And graffiti is not only tags. So while I was doing research in this stuff, I wanted to also find ways of generating more complex forms of graffiti. And what's difficult, again, looking back at design software and similar things, when you're creating graffiti, you often have those kind of overlaps of things that like kind of make knots and they go into each other. And that's quite complex, again, to create with traditional vector editing software. And again, you can think of graffiti as strokes, right? So you're actually thickening the strokes, you're giving them a volume. So again, I kept on going with the same line of work. The idea is you have a form of control polygon, and instead of creating a stroke that is a simple curve, you create kind of a thick stroke. But the challenge was how to do these overlap effects, right? So you have thing going over another, and if you have tried to do those things with Illustrator, they have, I think, a tool called Live Trace, but that's kind of can be tricky if you want to do those things quickly. You will need to start masking, removing parts, and what if you want to edit something? So here the idea is you can create different patterns that look like different forms of graffiti by using this basic control polygon approach. And here's an example, for instance, of using live trace in Illustrator, right? So here I'm actually masking stuff, but now what if I want to modify this S and change the structure? I need to start over, right? So the idea here was to generate an interface to help with this. And this is how it works. Again, you just click points, you make overlaps, you can change the widths based on like a chisel tip simulation. And then you can click around and change the overlaps quite easily. So again, this is designed to be an interface. And those are examples of things I designed by hand using this. And that's a quite quick process. So here I was trying to simulate different styles of graffiti described by Alessandro Ferri, is an Italian graffiti artist, in a very nice book, which unfortunately I think is still only in Italian. And yeah. But again, we have the similar concept, right? So we have a motor plan, a structure, a very simple structure, and variation of styles based on strokes that follow this structure. Those are not great examples, but yeah. But again, now the question was, where do I get those structures? And that's a challenging problem. So Douglas Hofstadter made a very early research, I think in the 80s, where he showed already how complex it was to simulate the variation styles of letters created on a grid, right? So similar to what we have seen before. And already, if you're working on a grid for a computer, even with AI, I think also with current methods, it can be very challenging to generate consistent typefaces or consistent letter structures based on this very simple grid. So if you think of those variations that are possible for an A, for instance, on I don't remember the number of points on the grid, but for a very small grid, think about the variations that you can have with fonts. So it's a very challenging thing to solve if you want to use, for instance, AI, and it still is. And my approach was, okay, we can actually think about some of those letters as stroke-based. So essentially, why not use so many fonts that are out there and extract strokes from them and then get structures from those letters since people have already made them. So a subset of those letters that you see here, you can actually use them for this task, right? They have a structure that can be recovered somehow. Well, this is turned out to be a very challenging problem and headache. But the results were okay. So here's an example of taking some fonts and then essentially reconstructing some form of stroke structure that reconstructs the font. Here this is kind of a single curve. And finding those like structural features, like so say where a stroke is hitting another, where they intersect, etc., etc. And then once you do that, you can start to apply stylizations, right? So you can transform, you can simplify those strokes, and then transform them, and then create different stylistic variations that resemble graffiti a bit. I'm not, as a graffiti artist, I must say I'm not happy with those results, but it works, and technically it's a challenge, so it's kind of an interesting problem from a computing perspective also. And here are some examples. And for instance, here you have this font has kind of weird kerning. I'm really bad with kerning, but also because I'm really bad with kerning, a nice thing in fonts, you get that information for free, right? So you can use the information that is embedded in the font to decide the distance between your letters. And here are examples of the system applied to more like calligraphic like stylizations of the input, right? So on the top you have the font, the letters put together, and below you have different stylizations created with the methods that I showed you earlier. And then here is where I start to have fun more in the artistic sense, right? So you can start to do strange things. And there is where I like it more, right? When you kind of go a bit more wild with aesthetics. Here is an example of an alphabet and a stylization combining the methods earlier, but without really worrying less about legibility. So those are just practical examples of things I've done. And so here you have, for instance, a lot of letters. And again, oops, somehow something's bad with the ordering here. Okay, I'll skip the slide. Okay, so again, we can use machines. I like working with plotters, and in this case, I can put any pen on the plotter. And here I use the calligraphic pen to create stylized alphabets, which are derived from a font. And this is a kind of a plug to a project we have now at Goldsmiths University and Constance, which is the German place that I showed you earlier with the robots. And we have a project where we're working explicitly on painting and drawing application with robots. So you can check this website. It's called equa.org. And then again, a plug, we will have a symposium and an exhibition in Berlin end of January. So if you are interested, you can check this website out. And here is a robot attempting to do calligraphy. Again, as a calligrapher, you probably will not be happy with this, but for a robot, it's okay. And more stuff like portraits I'm working on. Again, all the idea is like to try to reproduce those curves that look fluent and done with principles that are similar to what a human would do when moving. And again, wait, no, I'm going to go back again. Other experiments I did with the segmentation, so the division of fonts into strokes. This is an example of using like 2D animations on transforming in time the structures. And this is another example, again, plugging into Blender, doing more fancy rendering and things like that. So it can be fun. Once you have, like essentially I do those tools that I try to use in a researchy way, but then I try to use them in more creative applications. And here's another project I worked on, again with plotters. The idea, the plotter draws, right? And we know exactly what it draws. It follows some paths. And because we know exactly what the path is, we can use projection mapping to color the drawing in real time, because the computer knows what the machine is going to draw, and that paths can be adjusted quite simply with a perspective correction and adjusted to match exactly with the drawing. So in this case, you have a plotter. It's drawing some of the patterns generated with the systems you saw earlier, and the coloring is being done in real time with a projector. And the setup is something like this. It's very simple, right? You have a projector standing there, you have the plotter here, and it's projecting. Depending on the lighting, you'll have different effects. This was shown at the V&A in London. And here's an example of, again, going a bit crazy with the stylization. And here you have an example of a drawing made with the plotter, how it is colored with light. And here is an example of the drawing when it's finished without the light. No, it's not the same drawing. I didn't have a photo of the same drawing, but it's kind of the similar algorithm creating those. And then, of course, one of my favorite forms of graffiti art is wild style. So things get quite illegible there. So again, we can kind of deviate from trying to have things that are legible, from letter forms being explicit, although there's a lot of work I want to do more in this direction. Those are examples of wild styles. Most of them are quite old examples. And so the idea I had here is like, because wild styles are essentially, you have all those like loops and knots of strokes, essentially, like overlapping, going one on top of the other. So I decided to maybe look at start with a structure that is a knot in the mathematical sense. So like, like a mathematical description of a knot, and you can use a very simple one called the billiard knot, for instance, which essentially looks something like this. But then you can apply stylization with random perturbations to the points, and you get something that kind of looks like wild style with the right stylization parameters. So I kind of got into this rabbit hole more in an artistic sense by using the tools that I showed you so far. So those are examples of things I've done. This is like a print using that overlapping system I showed you earlier. This is just an experiment with more rounded shapes. And this is again an example of a plotter drawing this. Again, I kind of contrast, right? Like when I do graffiti, I'm very instinctive. I don't really think about it, and it probably looks good from far, but not very good from near. But machines allow me to do very precise things. So this is a very, very small, wild style like drawing being generated by a machine. This is another example where I should have added more information, but essentially the part below is made by machine and is completely generated with this knot stylization system I showed you earlier. And eventually on each line, I remove lines from them and I complete them by hand. So it's kind of trying to merge what I would do by hand and what the computer does. It's extremely tedious because it takes away from this instinctive thing that I have when I do graffiti, right? Not thinking and just doing it as it comes. And then finally, one thing that I was experimenting with was using stable diffusion and control net, those new powerful generative AI tools, and just using those vectors I generate with prompts to create images that I liked. And one thing I was like trying to with prompts that were like paper and things like that. And I was like, okay, maybe I should build it. So the idea here is like taking again to the physical world. In this case, the computer system essentially generates parts that I glue together and generates for me instructions on how to glue them together to recreate this kind of like graffiti paper knots. And again, another plug, because I'm teaching at Goldsmiths and for my own stuff, I've been developing this. I work mostly in Python, a bit of C++, but mostly Python. And I found that in the years, I've been developing different systems to work quickly. But lately, because I have students that work with processing, we switched to Python, and I've been developing a kind of Python processing version, which there are a few, but this one is more tailored at 2D graphics, and perhaps it has a spirit similar to Drawbot, which is a project I think initiated by Just van Rossum. But in this case, the idea is to have a Python system that allows to integrate all machine learning and the huge Python ecosystem that you have out there in a simple interface. So you might want to have a look. It's still in construction, but it's being developed. And yeah, so that's about it for me. And if you have questions, please ask. And thank you.
Thank you, Daniel. Very impressive, and you go so far away. And ok, est-ce qu'il y a des questions dans la salle? On a aussi des questions dans le chat. Donc, on peut commencer par la salle. Any question? Alors, non. So, I will read a question from the chat. So, it's from Maria Tan. She say, Daniel, which software do you use for generate your results?
So it's mostly all custom built. And so it's a lot of code I've been developing over the years. Some is already open source, and some I'm slowly open sourcing. And I initially, it's all custom built software. So a bunch of libraries. And initially I was working mostly with C++, and now I mostly work with Python, which makes things very easy and fast. Not fast as performance, but fast to code, right? So you can code in a faster way. So mostly Python.
Ok. Je repasse par la salle. Toujours pas. Bon. A second question from the chat. Why do you use old school graffiti for references?
That good question. But yeah, I'm a big fan of old school graffiti. I think that that's my personal taste. So also as a graffiti artist, I'm inspired by that, and yes, so that's also for now, like what I'm trying to capture is kind of like what I consider, right? It's very personal, but I consider the essence of graffiti, and so yeah, I found that old school graffiti, especially things that come from New York, but also a lot of things that come from Paris, from the Netherlands, Germany, England, also Italy. I find very inspiring. So it's a personal aesthetic choice, I would say.
Des questions? I have a question, me. So,
Yeah.
who is your research accepted by other scientifics, and which department work with you? Just engineer and any other?
That's interesting. So yeah, like it's accepted. A lot of the work I did in during my PhD has been published in mostly computer graphics venues, and it's interesting because I have this kind of like weird, I'm kind of in a weird middle ground, right? So my graffiti friends think I'm a weirdo because I'm doing all this code-based stuff, and the computer scientists think I'm a weirdo because I come from graffiti and I do all this graffiti stuff. But there's interest because there's, like, in my case, I have this expertise in graffiti, like from experience, right? And I have the know-how on how to build the systems that and describe the systems that allow to generate it, right? And people I've been working with, a lot of the work I've done is thanks to collaborations. A lot of it is, yeah, with my supervisor in Goldsmiths, Frederick Follemarie, and Sylvain Calinon, who is a roboticist. He works in Martigny in Switzerland, and he taught me a lot about curve generation in robotics, and we still work together. Hopefully, we have some new stuff coming soon. Then I've worked with researchers in Israel in computer graphics and people in motor control. So yeah, there is interest interest in those fields. Yeah, I don't know if I answered the question right.
Thank
If I
you.
answered your question, essentially.
Par la salle. Here, there's a question or another one in the chat if you want. Okay. All right. Just I have to translate it. And so from Sandrine Wee, she say, I see he spoke about wild style, but what is it about block letters, for example?
Yeah, block letters. Well, in a way, block letters, there is, if you think about, then again, the definitions in graffiti are very variable. Again, like some graffiti artists will be pissed that I say graffiti, but I say it, you're supposed to say writing or also art. But block letters are very, like, in a way, you're trying to reproduce a font when, in many cases, right? So I found it less of a challenge and less of something to research. So I was more interested in doing things that are more complex. Again, it's a personal choice. I'm not. One thing I need to point out: I'm not. I'm not trying to create a tool, and I'm kind of against tools that, website generate your own graffiti kind of thing, right? So for me, this is more about exploring elements in geometry or computational methods that allow to capture certain elements of a style, right? But I'm kind of skeptical about a system that generates those things automatically. I think more about tools that I use as an artist personally and perhaps can be useful for the wider community in different ways. So So I'm not aiming at having a system like write your name in graffiti style. That's not my goal.
So, okay. Thank you, Daniel.
Yeah, thank you. Bye.